3, 2, 1.
All right, welcome. Thank you for joining me today for Foundation of an AI Roadmap. My name is Olivier. I've worked for 20 years in the software development space, focusing a lot on data and machine learning. Background is definitely as a developer, but have worked in leadership roles as a mentor, work at the university with students, sort of bringing up the next generation of software developers. I'm also co-founder of a startup, an occasional instructor at the university. Now, before we dive in, I do want to comment on there's a slight delay in the broadcast. And so as you go, if you have any questions, please do put it into the chat right away. And then we'll have a little bit of a pause later to answer some of those questions. Unfortunately, it won't be very interactive, but put your questions in as soon as you have them, and I'll try to address them at an appropriate break. When we talk about artificial intelligence, people think of all sorts of projects. They think it's going to solve their operational efficiency, their pricing, the marketing, and then it applies to many different areas. It seems like everyone is doing AI, right? Everyone's thinking their competitors are doing this, and it's necessary to do something with machine learning or artificial intelligence to stay competitive. Now, there are a lot of broad claims that people make about this. Now, is it really all true? We're going to explore a little bit sort of the realm of what's possible with artificial intelligence and how it could benefit your company. Now, artificial intelligence is not able to solve broad process questions. So if there's an organizational process that you have, that is something that humans need to look at and understand some of the trade-offs and the efficiencies and maybe adjust some of those processes. AI is really good at interpreting data and answering very specific questions. So if we take an example around operational efficiency, we're not able to say, AI is not going to tell us how to change our overall business process. But within that process, if we're able to identify an area where additional information or new insights would help us to be more efficient, we can use AI in those spaces. So an example would be a manufacturing plant, and there may be a machine that can be tuned, where AI is not going to tell us how to change our entire manufacturing process. But if we look at a given machine that may have some parameters, that maybe there's a certain speed of input or the amount of input that we can look at this machine. And so we're going to tune it so that we are getting different outputs or able to get more outputs or reduce the errors that the machine is producing. Normally, if we run things faster, there may be more errors or little hiccups within that machine. And so an artificial intelligence system would be able to help us understand from our previous data what may be the appropriate parameter given certain inputs. We can also look from a marketing perspective, understanding user segments. It's not going to tell us everything about our users or say which users are the best suited for a given products, but an artificial intelligence system will be able to look at our prior data that we may have and understand how users interact with a given product. And so we can start to build out potentially recommendation engines or segmenting our users in a way that we can have more targeted campaigns for those users. So we'll come back to this, and I talk often about just having a very specific question for an artificial intelligence system to be able to answer. Now, when we talk about artificial intelligence or the related projects, we often end up with a bit of a word soup. There are many words being thrown around. Some of them are very similar, some are interchangeable. So I want to take a moment to go through a few of these definitions and really understand what are some of the key concepts and what does it mean when we use some of these words? What is the scope of it? Some are more precise and some are more broad. I want to start off with artificial intelligence. In the title of this talk, artificial intelligence is really the artificial version of what humans would describe as intelligence. as humans, we have this intuitive understanding, and it may be from observing nature, observing animals, that they behave in a way that we think that is intelligent. It demonstrates intelligence, some level of awareness, and processing of information that drives the behavior. And so artificial intelligence is about creating a computer system that mimics this somewhat intuitive definition of intelligence. I've looked for definitions and no one is really able to clearly articulate what is intelligence. What are the properties of intelligence, and can we really define it very clearly? Unfortunately, it is just human intuition that we look at something and go, wow, that seems intelligent. And we look at some other process and say, well, that's just a normal physical phenomena. Water flowing down a hill is just basic physics. There's no intelligence perceived there. However, when I look at, for example, the dogs that I have at home, when somebody comes to the door, they're able to recognize different people and the reactions are different. There's a demonstrated intelligence there. And so artificial intelligence is trying to mimic those similar behaviors. And so it is a fairly broad term. Artificial intelligence does not specify a particular technique, but it describes this overall perception that we have of the behavior of the systems, the appearance of intelligence. If we look at particular techniques, there is another broad category called advanced analytics. So in the past, we've had business intelligence, we've had some data analysis that we can do, and this gives us a sort of a basic understanding of some of our data, and we're able to generate some insights and maybe some very basic predictions for simple problems. Advanced analytics is a discipline that is now bringing more complex methods that include potentially machine learning or more advanced statistical models to be able to understand what is in our data. We're able to get insights and make predictions for our business. So again, this is a fairly broad umbrella that may cover some data analytics, data science, some visualization, and some presentation of the data. So this is a term that's a little bit more implementation focused, saying it's a collection of methods that we may be able to use. Now, there is a lot of talk about big data. And what does this refer to? It's really about not necessarily just the volume of data, right? So it's not just that we have many, many petabytes of data, but it's really about the sources of data, the structure or lack of structure in the data, and the various formats that are coming in. And so big data is more about a collection of potentially mismatched data coming from many different sources. It's often data that doesn't neatly fit into a relational database. Big data often ends up in a data lake where it's minimally interpreted, but we're storing all of this data that is coming in. Big data is often also streamed in. So maybe we are reading from IoT devices or sensors from the field every few seconds. That data stream coming in would fall in this big data category that we're able to store for later processing. And so really one of these properties with big data is that we're not forcing an interpretation on that data as it comes in. We're intentionally deferring that to a later stage when we want to take on some techniques like the advanced analytics. Another keyword that comes up quite often is data science. And really, the two words really describe it quite well. There's data, so it's based upon often big data, a large volume of data that we want to interpret. And the science part really refers to the empirical nature of the process. There's no direct way to say this data is going to turn into this predictive model, right? It's a scientific field where we have to experiment. There are many different types of models or statistical analysis that we can perform. And the science part here is that from intuition, we may have a few ideas what to try. We're going to try that, look at our results, and then iterate on our approach. So that's the data science as a discipline that itself includes different methods from statistical analysis and then machine learning being one that is becoming more popular recently. Now, when we talk about machine learning, we are now talking about a specific technique. Machine learning is contrasted with what we call traditional programming. So for many decades, computer programs have been built by a programmer who is defining the logic and the steps that we need to take to complete a computer program. So the logic must be well understood by the human who is inputting that into a computer. Machine learning is sometimes referred to as software 2.0. It's a new paradigm in programming where the computer is able to learn from the data that it's given. So we talk about examples, and so potentially if I want to identify cats in a picture, I would give it examples of cats, cat images in the computer, as well as maybe not cats. So maybe I have tigers and mountain lions that are negative examples. So the computer is able to automatically fine-tune its recognition of a cat. And so the computer program has two parts. It has the learning framework that a human has to create, and then the computer's internal programming that uses the framework to generate what we call the model, or its internal representation of the logic needed to identify the cat or to perform the particular predictive task. Take a brief pause to see if there are any questions so far in the chat.
We do have one. It says, I've been hearing a podcast, and in there they say that intelligence is the ability for something to face some situation and being able to adapt and face it effectively.
Yeah, I think that would be a reasonable definition of intelligence. There are definitely different approaches, and from a philosophical perspective, there are people looking at how do we actually define intelligence in a more structured way. And yes, I think it's reasonable to say that facing a situation, we're able to react in a way that is reasonable or maybe rational. And so it's, without trying to get too fine of a point on the exact definition, yes, I think intuitively we have that understanding, and a computer program may demonstrate intelligence, and we may say it's intelligent when we look at it and say, wow, that is a reasonable outcome that it has. And so it doesn't feel like it's just, it goes beyond the very basic logic for sure. Okay, were there other questions?
That's all we have so far.
Okay, excellent. We'll take another pause in a few minutes. But next, I wanted to look at the sort of the building blocks of an AI roadmap. So I'm going to look at a few different components separately, and then after that, we'll come back to pull it in together. So I want to talk about three pieces really that are the key to understanding our approach to AI and how we can go about building out projects and using it within our business. So a few months ago, I did a talk really much more focused on data and how we can leverage data for our business. So I'm not going to repeat all of this, but really the key points from that were that we need to understand the data within our organization. And the way I think of it is it's broken down into two components, the intentional and the implicit data. Now on the screen, I do have a few examples, but I want to talk a little bit deeper about what this means. The intentional data is what we would typically find in our database. It's what we modeled as part of our product. So if I'm making a web-based forum, I'm going to have users. I'm going to have some demographic information and the content that the users create. This is sort of your, or almost explicit data, or things that we intentionally are making part of our system and that we're capturing in our database. This is what we often think of as data when we look at a computer system. Now, similar to an iceberg, there's implicit data, which represents all the things that isn't immediately visible, and often it is much larger in volume than the intentional data that we're creating as part of our system. Implicit data is generally created by the users through their usage of the system. So it may be usage patterns or interactions with the system or feedback that they're able to provide into the system that we can use for later analysis. Now, what's interesting with the implicit data is that it's not necessarily just individual data points. Now, we may note that the user loaded a page or they filled out a form on our site, but also the timing of those events becomes interesting. And that's another layer of that implicit data. is the time series data that is implied by the sequence of events that are taking place. So when we look at our organization, we really want to have a good understanding of the data that we're capturing or the data that we could capture. Really pulling this together and saying, what is the potential for us to learn from this? And so part of an AI roadmap is it necessitates a large amount of data and a really good understanding of how the data relates to your business domain and how we could use this. And so one of these pieces would be, if you don't already have a good data strategy, or you don't have a collection of data from across the organization, would be to really map out a little bit, what are all the sources of data that we have? And some of this implicit data may be, for example, a company with a vehicle fleet. Maybe implicit data is the actual vehicle locations over time, or information about the exact timing of the different deliveries. So if we're sending out a vehicle for delivery, we know that the items are going to get delivered, and we track usually the delivery itself. But do we look at the timing, where vehicles are paused? All this information can become useful in trying to apply our artificial intelligence to our business. Now, coming up from the data, one of the other pieces is the advanced analytics piece. Now, we can have all of this great data, and we can generate some insights from it. But if we don't have a precise question that we're trying to answer, we're going to be going around in circles. We can explore the data, and there may be some interesting things, but we're not going to get business value out of it until we're able to formulate a specific problem statement and focus on getting the information we need to achieve a particular goal. Within the realm of advanced analytics, there are many techniques to choose from. There are some basic statistical models, there is machine learning, and within that also comprise a vast number of different algorithms that we can choose. So going into this is knowing that the advanced analytics space is empirical in nature. We have to be able to build, measure, and then iterate. Very rarely does our first iteration at solving a problem or answering a business question get the most accurate answer that's going to be perfect for us. Typically, we're going to start off and we may have a model that is 50 or 60% accurate, or makes predictions that are reasonable 80% of the time. Once we do that, we can say, is there business value? And then we can iterate and maybe build a model that goes, increases 10 percentage points. And it iteratively is going to get better as we learn more about that space. A lot of times, the business value that you get is early on. You can have a model that is 60% accurate and still derive good business value from that. And then there's the question of how much further do we want to iterate? So we'll come back to this business side of it in a moment. But with advanced analytics, what's important to note is we really want to start with the simpler algorithms. There are so many different techniques, some much more complex, some require data in different formats. And so it's really important to start as simple as we can and really focus on the minimum viable product. And a lot of times we can think about reducing the problem and saying, and accepting that we have a model that is less than perfect, but accepting that as the MVP so that we can validate that our complete concept actually still makes sense. If we want to later improve on our algorithms, we can then look at a little bit more complexity incrementally to try and improve the outcomes. But a key here is to always start with what is simplest for your problem domain, and then where justified, add the complexity. The third pillar, when we're looking at trying to put together an AI roadmap, is the business case. And from my experience, I've seen many different technology projects that start off, and people build some amazing technology, and then they start looking for the problem that it's trying to solve. And so this is really backwards in that you want to understand what is it that we're trying to answer. So we need to articulate a clear goal from the very beginning. You can look at data, and sometimes it's good to start off with some exploratory data analysis. We can look at and say, do we have some interesting data? Maybe there's something here that we can work with. But very quickly, we need to turn that into a business case. There's no point in pursuing this data for months on end to find maybe there's something there. We need to be able to focus in. One framework that I like is the OKR. And so the objective is really asking, what is it you're intending to accomplish? And you should be able to write out in 1 or 2 English sentences, what is it that you are trying to accomplish with this particular project? Or if you have an idea, okay, what can come from that idea? And then the key results is really about getting some very specific metrics, putting some numbers on it to say, we're going to improve the efficiency of this process by measuring the number of widgets that are produced in the plant. And maybe a metric for success would be an increase in 10% of widget productions every hour. So with the key results, it's really about being very precise, something that we can measure. So a vague metric may be it's going to be more efficient, or people feel better about the work that they're doing, or it's a little bit easier. These are too vague. And so we really need to focus in on very specific, tangible numbers, increases in production or increased sales revenue. Now, once we start formulating a business case around this, and we've got some OKRs, we understand our metrics, we now need to come back and really look at more closely, does the data that we have support the stated problem? So if we're trying to optimize our widget factory, but we have lots of information about our truck fleet, those are somewhat unrelated. So we need to make sure that we have the data about the widget factory that is relevant to the production. Are we able to measure the inputs, and do we have historical data on the inputs, the outputs, and different parts of the process? Sometimes as part of this exploration, we'll realize that we do not have the data to support our business case. So one option is to go back and say, can we collect the data? Can we add in some more data feeds or sensors? Maybe they already exist, or maybe we add sensors to be able to produce the data that we need to support this. Alternatively, we can look at different projects that we may have within our business where we have the data. Now within this, we also need to look at whether the business question that we're asking is suitable for the given analytical techniques. I've worked on some problems where sometimes the theory simply doesn't exist on how to solve this problem. And so it becomes much more complex to try and build a model to make the predictions that we want. And so really understanding what is the question you're trying to answer? What is the theory out there? What is the state of data science research? Does it support being able to answer that particular question? And the third point here is to assess, are you able to monitor the results if you were to make an efficiency gain? And so here it is really about making sure that you can reduce the delays in that monitoring. If your expected gain is 6 months down the road for a given prediction you've made, it's very difficult to correlate that back to a model. And so the empirical nature of this work starts to break down. And so you want to define metrics that you can actually measure on maybe an hourly or a daily basis. And now you're able to assess whether the techniques you're applying are actually meeting your goals, and you're able to iterate from that point. Take one more pause for questions here.
There's a couple more. One is, I'm trying to think innovative. So many companies are developing the Metaverse where people interact. Will artificial intelligence be used only by the creators of the Metaverse, or can the civilian players also contribute? Will all the data from this finally be used to create general intelligence?
Okay, a few questions there. Let's think about the Metaverse. It is being created by large companies. In terms of the framework, I guess, to support that Metaverse. And so there's access to a lot of data. But as an individual, we can already get large data sets from different government organizations or some of these tech companies. You're able to look up what is the search patterns. It's anonymized and aggregated data. We're able to get that data from a lot of these large tech companies. And so as long as the Metaverse is also built with some access to the data, anyone can really apply these ideas of artificial intelligence. We're able to access it and answer some of the questions that we have. So it may be, I find some interesting patterns, and maybe I want to build a plugin or an extension to the metaverse in some way that I interact. If I can get some of these large aggregated data feeds, I'm able to see some patterns and test some of my ideas. And so I think it is entirely possible for each person to leverage artificial intelligence. And really the underpinning there is that most companies are going towards APIs and exposing this information. And so, yes, I definitely think that artificial intelligence will move towards more of a commodity and democratize to some extent as people have access to the data and are able to leverage some of the tools. Do we have another question?
Yep, got another one. How would you approach on trying to eradicate the developer's bias so that they don't leak into the solution? Say, I like more blue vintage cars rather than vans. How would you realize that you could be introducing that kind of bias?
Yes, bias is definitely, there's growing awareness about the potential for bias and the risks of that within the data sets. They're definitely doing a statistical analysis of your data can help reduce that. But it's really be able to try and take a scientific look at the data and really try to take away maybe your own biases or preferences out of it. And maybe searching online, getting very large data sets where, maybe I prefer blue vintage cars, but if I search online, I can find data sets or at least information about the distribution of vehicles. What are the most popular colors? What are the types of vehicles? What is the distribution of vehicles on the road based on the age or the manufacture dates of the vehicles? And so with this example, we can actually pull that information about what we would expect to be in our data set. And so we could validate our data and try to reduce the bias by looking at much more global statistics, which our own data set should mirror. If we're only looking at, say, vintage cars, we can look at the global subset of vintage cars. But if we want to reduce the bias that I may have for those vintage blue cars, we can look globally and say, okay, what should I expect? And so I think there are these types of techniques that looking almost for sort of an external validation or pulling external data that isn't directly in our data set, right? So it's the metadata around it and helping to validate that we've reduced our bias. Are there further questions?
One more. A lot of my work deals with real-world data from physical sensors instead of clean computer-generated data. Can you comment on dealing with unreliable input data in models?
Yes, absolutely. So managing the data for our models is often said to be about 80% of the problem space. And so this is a very common problem to get noisy, unclean data, missing data values. What we're able to do, there is often a data cleaning pipeline that folks need to create. Now, most of this is going to require a little bit of understanding of the business domain. And so for a given sensor, you may be able to define reasonable values for that sensor. If it's outside of this, it may be that the sensor is broken or you're missing some data. And so there is the need to create some logic, and this is manually done. There's not typically a model for this. It's just manually understanding that business domain and translating that into valid ranges of values that we can have and filtering the data through that. There may be an option there as well to augment some of that data. So maybe we can, if we know that the sensors are reading something that doesn't change instantaneously. So it may be that typically the value being measured should follow a smooth curve. And so if we're getting bad data points within that space, we could discard those. And if it's necessary for a model, create data points that would match the expected curve or the trend within that sensor. So there are many different techniques that you can explore cleaning is necessary. in that you have to look from the business domain. Again, what is reasonable to expect? And then looking, is my model actually robust in the face of missing data? So maybe gaps are actually better than having incorrect or generated data. And so it's really understanding what is the behavior of the model if that's missing, and potentially changing the type of model or the techniques that you're using so that they are robust to missing or noisy data as well.
All
Was that
right,
the end of
that's
the
all the
question?
questions we have so far.
Okay, excellent. So building on top of the few separate pieces, I want to talk a little bit about thinking about this roadmap for your organization. So when we talk about technology, it's really easy to get sort of lost off into the details where we think, okay, I can build this model, I can keep building these better and better models to answer a particular question. But in putting together a roadmap, we need to step back and understand across our organization, where is the value that we could create? So part of this is understanding what are revenue generating activities within our business. What is our core business? Where is most of our revenue coming from? And where are the highest operational costs? And so profit for a business is going to be the difference between this revenue and your operational costs. And so you could increase revenue or reduce costs. And so it's really understanding where these are within the organization and trying to identify the opportunities to optimize. So if you have a cost, there are costs across different parts of the organization. So taking on a project where there is small costs already, there is sort of a maximum savings you're going to get, which may be small, and so it won't justify the project. What we need to think about is where are the larger buckets of either costs or revenue, where even a 1 or 2% increase in revenue or similar decrease in costs would translate to a fairly large impact to the organization. And so it's really trying to understand as a business from a high level, what are all of these key areas that we want to look at? By way of example, let's say an energy company may want to increase the yield from a given input. So from an oil area, we're extracting, can we increase the extraction by a few percent? And oftentimes that can translate to very significant revenue gains. Or maybe we can tune an engine that is within a plant, and tuning the engine itself consumes power. If we're able to tune it, we can have reduced power consumption and more efficient power output coming from that. And so it's looking throughout the business for these places where there are specific things that we can do. So it's not simply saying our widget production can be improved. It's looking deeper into all these business areas to say, within the widget manufacturing, what are the different processes that are happening within that? Maybe there are conveyor belts and there are machines and robots that are performing certain tasks. Are there ways that we can optimize some of this? Looking at bottlenecks. So if we wanted to increase production, you can step through and say, where is the bottleneck? And sometimes there's spare capacity in some areas where optimizing the spare capacity is not going to help, but we want to look at where's the bottleneck, because sometimes that will give us the biggest boost. If we have also, as an example, vehicle fleets. Our vehicles are making all of their deliveries, say, each day, and so overall it looks like we are being successful. But is there an opportunity for us to reduce the fleet or reduce fuel consumption of our vehicle fleet if we had better routing? So smarter routing would reduce the distance traveled or the time idling. Also, if you have a smaller capacity vehicles, how you pack the items into the vehicle or how you batch the different orders together is going to impact how many times you have to make stops or how many vehicles have to go out. And so really understanding each of these parts of the system helps us to come up with the good examples for projects that we could pursue. Now, once we identify different areas where we can optimize, what we want to do is go through a systematic process to model the potential gains that we would get from this project. And so this is not as much a technical exercise, but more of a mathematical model to say if we had a 2 or 3% improvement in this particular process, what does that translate to in terms of dollars for our business right now? Now, if you think about how you could implement this, you want to estimate the time and effort to implement a solution that would get you the gains on this project. And then that difference is what would look at the return on investment. So maybe a 2% gain in our process would translate to, let's pick a number, $500,000. Now we're going to estimate the effort to do that. If it's something simple and it's 2 developers for a few months, that $500,000 gain is well above the investment we have to put in to optimize that process. So now it makes sense to proceed. However, if getting that same $500,000 gain would take a team of 10 people a year, you're not going to get that return on investment unless you know that the solution will be used probably for a decade to pay itself back. And if you look across the organization, all these projects, and you apply the same type of models and estimates, you're now able to rank all of your projects based on the ROI. What are the gains on these projects? And then you can also prioritize based on the complexity of different projects. Some may be higher risk, some are lower risk. But now you can make an informed decision about your selection of projects that you want to pursue. Now, I'm going to talk about Iterate, a very agile approach, and I'm a strong advocate for agile approaches at every level of this process. And the two that I really want to point out is within a project and looking at the collection of ideas that we have. So when we've looked at our entire business and we've identified potential projects across the organization, we can then rank them by the return on investment, the potential gains, and including somewhat of the complexity or risk for each project. This is this backlog of ideas that we could pursue. Now, as we tackle one idea, we're going to take a project and we're going to iterate. The model development itself is iterative. There is no clear solution to say, I'm going to get this accuracy of a model the first time. And so it is itself iterative to produce models of the desired quality. And so this creates these two sort of nested loops that we have to iterate. So we'll select a project. We may make 1 or 2 iterations on that project. Now we need to assess, is this project, has it hit MVP? Is it meeting our goals? Are there sufficient gains that we've gotten? If we are successful to this point, we need to look at the project and say, would an incremental improvement in my model actually give us some more gains? So typically, as you iterate on a given project, you're seeing smaller and smaller marginal gains. And so when we talk about low-hanging fruit or things that are easy to access, a lot of times they're within the first few iterations of a project. So what's important in this process is to take a project, maybe take an iteration on it, reassess your ROI for that given project, and compare it to the rest of your projects. And so it's not about taking one project to perfection. Take a step on this project, reassess. Maybe there's another project that gives you better. Now it would be get better gains. So you go to project 2. Now, when you assess all your projects, maybe project 1 is now looking the next step would give us the next biggest gains. And then after that, maybe it's project 3 and 4. So it's really important to always step back at each iteration and reassess the potential gains that you would get from each project and be strategic about which ones you choose. If you have a larger staff and you're able to tackle multiple projects independently, then take the top 2 or 3 ranked projects, take one iteration on those, see how far you get, and then reassess the entire landscape of all your projects once again. Now, part of this process is not just building a model, but it's being able to understand, is it meeting our needs? Are we able to monitor this and actually sustain that particular model? So as you tackle one project, this is where I talk about investing sort of evenly and concurrently in bringing in the data that you need for this project, building the model and the solution around that model, and then the monitoring of that. So every model is going to need some sort of feedback cycle. So if we have a manufacturing plant, we'd have a model that's going to tune some of the processes within that plant. It's going to optimize a particular machine. But we need to be able to get feedback quickly about the actual performance of that machine. Sometimes the model will produce predictions that are actually slowing it down. And so we need to get that feedback, ideally within minutes or hours, but within a day may be acceptable. What we don't want is a monitoring system that is looking at our quarterly production and then giving us that feedback. It's now too late to adapt our model. And as part of this iterative approach, what I would say is always early and often look at the ROI for your projects, understand the business value, and what is the marginal business value if you were to spend a little bit more time on that project. And it's being willing to say this project is good enough, or we've gotten most of the gains we expected, and we should focus our efforts on a different project going forward. Now, one way to model this, to sort of capture a little bit the essence of this iterative approach, is the two loops. So on the left, we're really creating the ideas, doing a little bit of design around that, and then assessing the value of those ideas. Those go into the backlog, which we're going to prioritize. I'm going to choose one project. We're going to build and actually release that product to production. Incomplete projects don't deliver business value. So the key is to make sure that we start a project, get MVP, and push it out, make it useful, derive the business value we want from it, and then come back, reassess our entire landscape. Do we have new ideas? What have we learned from this initial project? Design, assess the value, reprioritize your entire backlog of projects and ideas, and then choose one, build, and then release again. So as you're thinking about your AI roadmap, it's really important to understand the iterative nature, in that today, I cannot accurately predict all the projects that we'll have completed in 3 years or even 1 year from now. But the roadmap should be an assessment of your overall organization, looking at the potential areas where there are gains. Where are the biggest costs or the biggest revenue generating activities? Let's have that breakdown as part of our roadmap and say, these seem to be the highest potential gains within our business. And then we can look at saying, okay, this is roughly the order of projects where we can actually investigate a little bit deeper as we go. So that is the talk for today. Thanks for tuning in. More than happy to connect. My information is on here. If you're looking for more information from Improving, we have training, we have blog posts, virtual events at the links there. I just want to check in if there are any last questions before we wrap up.
I don't have any more in my queue.
All right. Well, thank you everyone for tuning in. And if you have any questions that come up afterwards, please feel free. Send me a message on LinkedIn, send me an email. I'm more than happy to connect. Thank you.